Welcome to Aurora Chemistry for everyone. Ethers are the least reactive of the functional group. The cleavage of CO bond in ethers takes place under drastic condition with excess of hydrogen halide. We are here to discuss the reaction of hydrogen iodide with 2-methoxy-2-methyl propane. Let us see these reactions step by step. Step 1. Generation of oxonium ion. First, let us draw the structure of 2-methoxy-2-methyl propane. 3 carbon chain, and in the second carbon methyl group, also methoxy group OCH3. Remaining other 2 carbon we can just attach hydrogen atom CH3. So this is the structure of 2-methoxy-2-methyl propane when it reacts with hydrogen iodide. This hydrogen will attach to oxygen of this one and form oxonium ion. So due to this attack of hydrogen, this oxonium ion, that means that oxygen gets positive charge. The positive charge on that oxygen is unstable. Step 2 is a nucleophilic attack. So during the nucleophilic attack, the iodide ion acts like a nucleophile. Iodide ion is a very good nucleophile. Because of this oxonium ion, that means because of that positive charge on that oxygen atom, this bond between carbon and oxygen becomes weakened and it starts to break. So to understand better, let us draw that this oxonium ion once again for the step 2. Because of this oxonium ion, the bond between carbon and oxygen becomes weakened and it starts to break. Now, here is the question for you. The iodide ion will come to attack this carbon or this carbon. Because of this bond breaks, what will happen? Here, you see that this carbon is a tertiary carbon and this carbon is a primary carbon. What is tertiary carbon? A carbon which is attached to 3 other carbon is called tertiary carbon. For example, if this carbon is attached to 3 other carbon, this carbon we called as a tertiary carbon. The same thing you can also hear, this carbon is a tertiary carbon. So because of this tertiary carbon, now SN1 reaction takes place and this results in the formation of carbocation. Whenever you think about the carbocation, you should think about 3 things in your mind. Carbocation. Look at the T here. So it looks like a plus, so it stands for cation. Then whenever you write that plus, first you will put that 1. So you just imagine it is like whenever carbocation comes, it also follow that SN1 mechanism. Then again the plus sign, it indicates that addition. Addition means more number of the people. So whenever that more number of people is there, then it is like a unity is strength. So these 3 things you just imagine. So these 3 things you always remember. Cation, SN1 and unity is strength. So here if you look about this carbon contains 3 other carbon along with that. So unity is strength. So that means tertiary carbocation is stable. So because of this stability, now iodide ion will attack that this carbocation and resulting in the formation of tertiary iodide. So let us go for that third step. Step 3. This bond breaks and iodide ion, that is here it is a nucleophile, will attack to this tertiary carbon, leaving that CH3OH group, methyl group as a product. So let us draw it. So here CH3, here CH3, then here CH3, then after that iodide ion plus CH3OH. So the final product for the reaction is 2-methoxy-2-methyl propane. When reacts with hydrogen iodide, it gives methyl alcohol and 2-iodo 2-methyl propane. Thanks for watching.